Hi, everybody. Mary here. And this time we're going to spend a little time talking specifically about exactly what we mean when we say heat and temperature. Now, you might think that's kind of wacky because you totally understand what it means to be hot or cold. You know what it means when you check the thermometer and how cold your house is or how warm your house is. But in science, there are such specific definitions to heat and temperature. So let's go through these. Heat is defined as the total internal kinetic energy and potential energy of the molecules in a substance. It comes back to chemistry. It comes back to molecules. And it's a combination of both kinds of energy. Kinetic energy, if you remember, is energy of motion. So this depends upon how fast molecules are moving. Potential energy is energy of position. And when we talk about energy of position in molecules, what do we mean? We're talking about how far apart molecules are. Molecules that are close together have less internal potential energy than molecules that are further apart. They have more internal potential energy. In other words, you have to put in energy to separate molecules. And this all combines to create the amount of heat a substance is going to have. So how much heat something has depends upon its mass, or how many molecules are present, the temperature or the speed of the individual molecules, the type of molecules, whether it's carbon or hydrogen or oxygen or iron or zinc, and the distance between those molecules. And what do I mean by distance between the molecules? Where basically I mean, do we have a solid, a liquid, or do we have a gas? So let's go into this in more detail. Another way of talking about heat is to say that heat can also be defined as the amount of energy transferred due to temperature differences. So this is a different way of looking at heat. I've heard different professors of mine say, always remember heat flows. Heat moves from one substance to another. And there's a law, it's a big law in science. It's called the Second Law of Thermodynamics. And it says a whole bunch of things, but one of the basic things it says is heat always goes from hot to cold. So if you have a hot thing and a cold thing and you touch them together, the heat is always going to go from the hot thing to the cold thing and make a lukewarm thing. If you have a hot cup of coffee and you set it on your kitchen counter and you leave it alone, through time, the coffee is going to get colder and the room is going to get slightly warmer. That is a rule of science. It's just the way the universe operates. Now, there's a specific definition of temperature. Temperature is defined as the average internal kinetic energy of the molecules of a substance. If you recall, kinetic energy has to do with how fast things are moving. So what this means is hot objects have inside of them molecules that are vibrating very, 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 very fast. And cold objects have molecules within them that are vibrating more slowly. So if you have a cold glass of water, overall, the molecules inside of it don't have an awful lot of speed. They're kind of zipping around kind of slowly. But if you have a hot object, the molecules inside of it are just zipping around with an awful lot more speed. They are going faster. They have a lot of kinetic energy in something hot and a little bit of kinetic energy in something cold. A change in temperature is a change in the internal kinetic energy of the molecules of a substance. So if you have a ball that you're throwing this baseball through the air, that's the external kinetic energy. We're not talking about how fast the ball goes through the air. We're talking about the individual molecules of the ball. We're talking about putting that baseball in the freezer compartment versus taking that baseball and doing something dastardly to it, like throwing it in a bonfire. That's going to change the internal kinetic energy of the molecules of that object. Now, here's a weird thing about temperature. Since this is the average internal kinetic energy of the molecules of a substance, we are talking about mathematical average. You've been in enough classes in your lifetime, you've probably heard about a bell curve. If you take average of heights of all of the human beings that exist, average weights of all of the human beings that exist, average, I don't know, height of plants of everything that's out there, you're going to take a representative sample of data. Typically, you get this kind of a bell curve where there is a lot towards the center and very little on the high end and very little on the low end. Well, if you have any sort of object and you want to take its temperature, you throw a thermometer in there and take its temperature, the average kinetic energy is represented by the average. The temperature is going to give you a representation of the average kinetic energy of what's going on in that sample. So what that means is that if you take the temperature of a glass of water at any moment in time in that glass of water, some molecules are going to have a high kinetic energy and be really, really, really close to boiling. And some molecules in that glass of water are going to have a very low kinetic energy and be very close to freezing. And you might go, well, that's bizarre, but that's the definition of temperature. Temperature is the average. It's going to mean in this glass of water, you have some molecules going pokey, pokey, pokey slow, some going zippity, zippity quick, and everything in between. Now, I can demonstrate to you that this happens. If you take a glass of water and you find its mass, so you know exactly what the water level is, and then you leave it overnight on your kitchen counter, will there be exactly the same amount of water the next day, 24 hours later? If you are really careful and measure it by mass, not just by eyeballing it, in 24 hours, will some of the water have evaporated out of your glass? And the answer is, well, of course it will. Some of that water will have evaporated in 24 hours. Well, evaporation means to convert from a liquid to a gas. The only way that happens is if something gets over 100 degrees Celsius or above boiling temperature. Well, we're talking about a glass of water on your kitchen counter. And I hope your kitchen counter never gets above 100 degrees Celsius, because that would mean you'd have a horrible tragedy like a house fire, and I certainly don't want that to happen. So how in the world can you have less water overnight? How can you have water evaporating off of this glass when your kitchen counter never gets that hot? That is because of the definition of temperature. In this glass of water, some of the molecules are really, 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 really high kinetic energy. They are moving crazy, crazy fast. And overnight, the molecules that are going crazy, crazy fast have enough speed, have enough kinetic energy that they actually escape the surface of the water and leave. And when they leave, they actually remove some energy from the cup. Now, if this happened quickly, not slowly, like over a 24-hour period of time, but quickly, you took off the fast, high kinetic energy molecules, what would happen to the overall average if you took the high end out? Well, the average wouldn't be here. It would push the average down, and the average would then be there. So the average would then be cooler. This process is called the cooling effect of evaporation. And the cooling effect of evaporation is something that you see all the time. This is how the human body cools itself. You perspire when you exercise. The body's beautiful cooling system, water evaporates off your skin, which means it goes from a liquid to a gas, which means the molecules have enough kinetic energy and enough speed to vaporize, and the high kinetic energy molecules leave, and the overall average goes down, and it cools your body. Why do dogs pant? Well, they don't have sweat glands, and so water evaporating off of the little doggy's tongue cools down the dog because the high kinetic energy molecules leave and cools them down. When you get an inoculation and the wound or the area is cleaned with alcohol, it feels cool. And the reason it feels cool is because heat is being removed. The high kinetic energy molecules of the alcohol leave the area, and that leaves everything feeling cool. Why are old-fashioned water bottles, why were they covered in canvas? Well, they had a tendency to sweat and they evaporated, and the water that evaporated off of them actually cooled the water inside. Old-fashioned water coolers, before there was electric water coolers, were big crocks, and water that would evaporate through these slightly porous exteriors cooled the interiors. I've had many students through the years that are military veterans, and they would tell me stories about being deployed in desert climates. And in order to get a cold drink of water when they're out in the middle of the desert, very often they would take a sock, a common tube sock. They'd take a bottle of water, put it in the tube sock, and then pour a little bit of water on the outside of the sock. Then they would then drive across the desert, and what would happen is water would evaporate from this tube sock, removing heat from the water inside, cooling the water in this water bottle, and they would end up with a cool drink of water. Cooly stuff. That was a weird word. I don't know. Temperature. Here's a question I love to ask on tests and quizzes, and this is the question. What device is used to measure the average internal kinetic energy of the molecules in a substance? Well, it's a weird way of asking the definition of temperature. And temperature is defined as the average internal kinetic energy of the molecules of a substance. So what device do you use? You bet. It's a common everyday thermometer. See you later. Bye-bye.